screw this up this morning. See if I've got any takers on the. Okay, so let's just go through kind of what we did yesterday, and kind of review our vocabulary here quickly. So, piecewise functions yesterday, our question was, how can you describe a function that is represented by more than what? Okay. I was really concerned yesterday that we tried to remember this, and you guys remember what this form was called right here yesterday? Slope-intercept form, where the value out in front of the x is my what? M, or M is going to represent the slope, so my rise over run. If my slope is 3, my rise would be 3. What would the run be here? 1. And then what would my y-intercept be right here? -7. So we were going to graph some things in slope-intercept form, and I think we've got a pretty good handle on it. The problem is going to be, where are we going to graph that? What intervals or what parts are we going to graph this in? Okay, so that's kind of the essential question we're after right there. And kids, the goals that we talked about yesterday was to evaluate some piecewise functions. This is pretty easy, okay? This stuff right here, that's pretty easy. I think what's going to be new for you guys today is to, these two in the middle, graph and write piecewise functions, and then to write some step functions. So I think that these two goals that we need to accomplish will be something that's very new for you today. And then we're going to work on writing absolute value functions, but we're going to write them as now piecewise functions is what they're called. Okay, so we got through the, I believe we got through all the vocabulary yesterday, didn't we? Can I see real quickly just to make sure we got everything down? And everybody was here yesterday. Awesome, this looks good. Let's talk, okay? So I think let's head on over to example 1 here. I think that we've got all of these terms down. Piecewise function, this was an example, 2 different parts of it. Something graphed left of 0 and something graphed right of 0. Talked about a step function a little bit. Absolute value functions were pretty good on. Vertex form and vertex we covered in the last section, and we got all that down yesterday, so I think we're ready for page 2, kids. Okay, let's talk here. I have a piecewise function up there. Again, a piecewise function is made up of more than one function. How many functions are in this first piecewise function in example 1? There are 2 of them, right? There's this top one and there's this bottom one. Now, kids, this here says you're only going to graph right here. You're only going to graph x minus 2 as long as your x values are what? Less than or equal to 0. Okay? So basically negative numbers, right? So if I have a negative number to input, I would input it in this x minus 2. But it says graph 2x plus 1 right here if what? Okay, so let me ask this. How about I give you an x value? Okay? I'll pick my favorite number. Is that okay? 6 is my favorite number. Would I put 6 in this first function to evaluate it, or into the second function to evaluate it, and why? Miss Sally, what do you think, kiddo? Yeah, I'm saying we're going to use 6. How many agree with what Allie said? She's going to put it in the second function because 6 would satisfy this parameter that it's greater than 0. All agree there? I don't want to put it into this first function because if I want to put 6 in, it says, ooh, this function only works if the number I choose is less than or equal to what? Is 6 less than or equal to 0? Absolutely not. So is 6 greater than 0 here? Okay, so if I had to evaluate 6, Allie, if I plug 6 in here, 6 is greater than 0, so I want to plug it into 2x plus 1. What would 2 times 6 get you? And then plus 1 more. So if I input 6 into that piecewise function, the output would be 13. Okay? So let's have you guys try this real quickly. Let's do one together. All right? This is a piecewise function right here. I want to evaluate this when x is equal to -1. Okay? How many think -1's going into the first equation? How many think -1's going into the second equation? All right, well, let's talk about it, guys. My x value is -1. If I check this parameter, is x, -1 in this case, less than or equal to 0? Yeah, so I'm going to say we have to put this in the first. Put this in the first. Put this in the first equation because what, kids? -1 is less than or equal to what? So to evaluate, this is what we get.
You infer all that?
Not really. But I put it up there just in case you forgot and looked back, okay? So if I put -1 in up here, this would become -1 minus what, kids? What is -1 minus 2 more? -3, okay? Looks like my bank account all the time with those negative numbers. All right, -3 is what we get. Give me a show of hands on the next one. How about in that piecewise function over here, f of x is equal to x minus 2 if x less than or equals 0, and f of x is equal to 2x plus 1 if x is greater than 0. Give me a show of hands what you think the evaluation should be for that piecewise function when x is equal to 3. When you think you know it, raise your hand. When you think you know it, raise your hand. Alexis, you want to help me out here? Second one? Way too many Alexises in the front row today. Okay. Yeah, and the second one, plus 3 is greater than 0. So what's 2 times 3, Miss Nasco? 6 plus 1 would be 7. So when x is 3, we would have 2 times 3 plus 1, which is equal to what, kids? Okay, give me a show of hands. How many are, I think I can evaluate these. I think I've got this. Okay with that? Okay, now I want to just talk about some notational things. How many functions are in this next piecewise function over here? There's 3 of them right here. F of x is equal to 3 if you're less than -2. X plus 2 if you're less than or equal to 5, but greater than or equal to -2. And 4x if you're greater than 5. These notational things right here say evaluate f of 8. This is basically check the function when x is what value, kids? 8. So in this first one right here, kids, is 8 going to be less than -2 when I check that first parameter? Nope. Is 8 going to be between -2 and 5? Nope. How about 8 greater than 5? Yeah. So I want to put it in 4 times x. So this will become 4 times what, kids? 8. This will become 4 times 8. Which is? Okay. You guys evaluate f of 0 real quickly and check with a neighbor. Make sure you agree. Or check with someone around you and see if you agree. F of 0. When you got it, raise your hand. I'll take a peek at it, okay? Good. Got it now? Good. Anyways, Sam.
What?
Okay, you're checking to see if 0 falls into the first, second, or third parameter here. And if it does fall in the first, it would just be what? If it fell into the second, you would have to do 0 plus 2, or if the 0 falls in here, you would have to do 4 times 0. Got it? Okay. All right, so let's talk about this real quickly, kids. The first parameter says my x value has to be less than what? -2. Well, guys, is 0 less than -2? No, so this one's out. How about the 0? Is 0 bigger than the -2 but less than the 5? In other words, does it fall between -2 and 5? Oh, good. So if that's the case, which function do I want to use? And what is the x value we're concerning ourselves with? Heck yeah, so this is going to become what plus what? Plus 2. I don't write very well left-handed. I learned that today. What do you get for a value then? Awesome. How many had 2 there? You on board with me? Okay, I'm just going to make a note. When you are evaluating a piecewise function, step 1, check your what? What do we call these over here? Your intervals is what they're going to say. I call them parameters. We like to sound like smart peoples. Plus parameters starts out like parson. Check your parameters. Where's it going? And then figure out which one of the parameters works. Then just evaluate them. Okay, check your parameters, then evaluate, okay? That's a pretty nice handwriting, all right. Like that one? Peanut butter and jealous all over, I can see it. I like example 1, evaluating piecewise functions. I like what I see. Okay, that's too easy. Let's make this more difficult. This is where things get pretty important. Okay, are we familiar with domain and range, kids? Okay, the domain part covers which values again? X's or Y's? Whoops. The range is going to cover some. Okay, so here's what I really want to talk about. Okay. This is where things for kids can start to get kind of confusing, all right? First thing I always tell kids is this. Look at your parameters first, okay? What value or values are really concerning our parameters, or what values show up in our parameters? Comparing X values to what? To 0, right? Okay. I'm going to blow this up a little bit. First things first, are both of these in slope-intercept form? Negative, this is really negative 1x plus 2, isn't it? Isn't this really like 2x plus 0? Okay. Guys, here's what I like to do with these here. I like to break my stuff down wherever there's a parameter. And the first parameter says we're going to talk about 0 as a parameter. So sometimes I'll come in here and I will draw like a dotted line where the parameters are. That helps me a lot to visualize this. So here's what I'm going to do. At x equals 0, right here, I'm going to draw a vertical line through that, kind of like this. Okay? So there's my dotted line. So here's the deal. The first thing I'm going to graph in this one right here is I'm going to graph the y equals negative 1x plus 2 here, kids. But guys, that negative 1x plus 2, I need to know, am I graphing that left of 0 or right of 0? Where would I graph that? Left of 0 or right of 0?
Yeah.
Why left?
Plus 2.
Okay, say that again, Sam.
It goes left because it's plus 2, right?
Okay. So your y-intercept would be plus 2, right?
Yeah.
But what x values are we graphing, kids? Are we graphing x values less than or equal to 0 or greater than or equal to 0?
Plus 2.
Okay, this is kind of like saying graph when x is what kind of a value then? Negative. So would that be left of 0 or right of 0? Okay, good. So let's do that. I know that I've got to come over here. Now, kids, this is the deal. And this is where things get tricky, because sometimes you'll have a point on the wrong side and you're going to have to get rid of them. But in this one right here, what is the y-intercept? 2. So I would come up in here and I would say, okay, I'm going to plot a 2 right here. My y-intercept, I'm going to plot 2. Actually, yeah, I'm going to go with it. Okay? I want to ask a question here. Should that 2 be an open dot on that dotted line or closed? Take a look at this sign right here. closed. Okay, now what's the slope for this? -1. Well, okay, I could come down 1 and over 1. Now, I'm going to put this point right here, kids. But here's the deal. You told me I had to graph that -x plus 2 to what side? Okay. This point's on the right. That's not going to be good for us. But don't these 2 points at least determine that line? So if I would say, well, here's my straight edge right here. Guys, the only thing I'm going to graph here then is from, I'll do the best I can. But I'm going to graph from here all the way this direction. Does that make sense to you guys? Am I going to the right with this? No. So am I going to have to keep this point or get rid of it after I've drawn my line? Get rid of it. We don't want to be over there. So here's what I'm going to do. I'm going to draw my line for that one. And it's going to look like this. Do you guys want a ruler? Whoops, I don't want it to be dotted either. I don't want to do that. I don't like that. Me no likey. Me no likey. Oh, this more gooder. Okay, you guys kind of get the idea there? I don't even know what my rulers are, so that's for slack, probably stolen. Okay, what do I want to do at this point right down here? Get rid of it. It's gone. Okay. Is this dot an open dot or a closed dot? Closed, because it equals 0. It includes 0. All right. Now, talk to me about this next one, 2x, kids. This says graph if x is greater than what? 0. Okay. I'm going to write this down here. This is going to be like to the positive side. Okay. This was like negative values of x. So what's the y-intercept in this 2x plus 0, kids? So I want the y-intercept to start at 0. Would I be open or closed on 0 given this sign right here? Open. So I'm going to say, okay, I'm open here. All right. How about the slope then through that? I'm going to rise 2 and run 1 to the right. Is that okay if this point's on the right side? Yep, because it's greater than 0. And then the next thing I want to do, just connect those 2 points. Start where your intercept is. There's that piecewise function right there. Okay. This graph right here on the left is the -x plus 2. That's that part. And then the 2x plus 0 is that line right there. Let me just show on hands. How many are on me with at least the first graphic part? This gets tricky for kids, all right? Trust me, it gets tricky. And I'm going to have you try one here in a second. Let's talk about the domain. Okay? Now remember with absolute value functions, the domain was pretty easy because it was what? It was all real numbers all the time. Now take a look at this right here, guys. Does this continue to go all the way left? Does it continue to go all the way right? Okay, but I have a break right here. I get to 0, so it looks like 0 is included, and then everything, is everything to the left of our break included? Is everything right to our break included? And is there a closed dot on our break? So it looks like to me, going left and right, how many points are covered? All of them. So what's it look like the domain might be in this situation? All real numbers again. Yeah, so, gosh. You know what? If I were you guys on a test or a quiz and I wasn't sure about domain, you know what I'd probably write down? All real numbers. Pretty good chance you might get it right. Okay? Now, that's not going to be the case all the time with piecewise functions, but in this case, all real numbers. Now, talk about your domain. And then, I'm sorry, the range. The ranges start to get a little tricky. Okay? Sometimes there's points that don't get included. Okay? This one here, it looks like the left one's going up and the right one's going up. So is there an absolute lowest point somewhere? Where's the lowest point at? Right here at 0. Okay? Now, is that 0 included or not included since there's an open dot on that? So the range value is going to be all y values above or below 0. So what's your range going to look like when you write that in terms of y, kiddos? What would you write? All y values greater than 0. Allie, was that you that said that? Okay. Good. Very good. So all y values greater than 0. Yeah. How come I didn't put equals to in here, guys? Why didn't I put greater than or equal to in here? Not equal to 0. Okay. So what I'd like to do, kids, is this. I'd like to give you about 3 minutes and 14 seconds. Let's give you about 3 minutes and 14 seconds to take a shot at this. Same game, kids. What parameter value are we kind of working around again? 0. Okay? So go ahead and see what you come up with there. If you want to bounce ideas off of each other, go ahead. I'm going to turn attendance in while you're doing that. So you have the piecewise function. There's two parts, y equals x plus 1 and y equals negative x. And you kind of have a parameter around 0. You're going to be to the left of 0 and to the right of 0. Questions or not? What do you think you do? What do you think, Costa? So you just start at 1 with this, and then your slope is the maximum 1. Okay? That's kind of the right of 0 and left of 0. Go ahead and raise those two. We're going to go ahead and do this. Just kind of follow along. Okay. Yep. So on this line, if it would continue, you're right of 0. Now if that line would continue, you would start here and go. That's where things get tricky. And I'm going to do something a little differently here to help you, okay? Okay. I'm seeing some good things and I'm seeing some common mistakes right now. So here's how I want to start this, okay? I think in this next example here, I want to try and do some things, all right? The first one, I have no doubt that you guys can graph slope-intercept form. I think you guys are very good at that. Okay, so let's talk about this first one. Kids, here's what I like to do. We know that our dividing line is where, first of all? 0. So it's going to be the y-axis again, right? Okay, just help me get 2 points plotted to be able to draw this line first. What's the y-intercept? 1. What's the slope for that? Now, rise 1, run 1. Now, I saw a lot of people draw their lines and go that way. Okay, but before you even draw your line from now on, have your 2 points there. We're going to just use those 2 points to draw our line, but we're not drawing the whole line before because we've got it either left or right of some kind of parameter. Here's what I like to do. This first one, this x plus 1, I know this draws my line, and I can go all the way across. For x values less than or equal to what? Okay. Ask yourself, would I be left of 0 or right of 0 for this one right here? I'm going to put an L up here for I go left of 0. So when I'm drawing my line, kids, I want to start at 0, so do I want to go up and to the right or down and to the left this way? Okay, is that going to be an open dot on 1 or a closed dot on 1? Okay, so here's what this will look like. Closed on 1. That's what you're going to see right there. Okay? Now let me ask a question. Does it make sense to ask yourself to go left or right up here based on this of 0? I saw a lot of people that went what direction? Right. Okay? All right, so let's do the next one. Oh, by the way, after I've drawn this line, do I want this point here anymore? No. Okay, so kick it out. All right? Kick it out. Whoops, I want the other point in there like that. Or some durka, durka, durka. Okay, how's that look for that first one? Is this the line? Is my slope positive 1, kids? Is my y-intercept 1? Am I left of 0? Did I include 0 on here based on that equal sign? I'd say that's pretty gnarly then. Okay? Now, somebody talk to me about this next one, because man, I'm lost. This is like negative x plus how much, minions? So what's the y-intercept going to be for that? 0. I'm going to put a point here. 0. How about the slope for that? So down 1 over 1. Okay. Now before you even draw your line, say, okay, I know that 0 is kind of my divide line, but those are the 2 points that are going to make my line. I just need to figure out what part of the line goes where. Let's see, x greater than 0. I'm grabbing this for all x values greater than 0. So is that right of 0 or left of 0? Right. Back to the right to the left. To the right, to the right. Okay, would I be open or closed right here, kids? Open, because there's no equal sign down here. So I'm going to draw my line. I don't like that point there. I'm going to get rid of that first. You naughty. You can go bye-bye. Time out. Open at 0, right? And then here we go. You draw your line just like this. And you get done at this thing and you look at it and you're like, yee! That's awesome. Live action stuff, awesome. It is live action because we're streaming this if anybody wanted to be watching. What's it look like the domain is again, kids? All real numbers. All real numbers every time is boring. It's like watching the same movie over and over. Does anyone ever watch the same movie over and over again? Who does? What movie?
The Grinch.
Oh, okay. I can buy with that. The cartoon one or the one with Jim Carrey in it?
Jim Carrey.
The Jim Carrey one? Good for you. I like that movie too. My movie is the Blues Brothers, okay? But that means that that's a movie that your parents probably like that movie. I'm probably older than some of your parents. That's, oh boy. The domain, all real. Oh gosh, good gosh. It's not the Grinch. The Grinch is kidding me already. Hey, how many days till Christmas already?
29. It's like 16 weeks left.
27.
It's like 85 days till Christmas, I think, isn't it? Okay. How about the range in this one? Allie, help me, kiddo. Yep, 1's a high point right here. It covers everything. Y less than or equal to 1. Very good. Okay? It's going to take some practice, kids. Let me ask a question. When I was drawing my lines, does it help you to ask yourself, do I go left or right at that parameter? Does that help? Okay. Remember that. When you get ready to draw your lines, say, am I left or right of 0? Now, is your parameter always going to be 0 here? Might be 2, might be 4. In fact, let's look at something here. Okay? You guys got everything down on that page? All right, let's take a look at it. Next page. You ready? Ooh. Guess what we have to do here, kids? Instead of graphing, what do we have to do? We have to write it. Okay? And it's not that big of a deal. We're going to do just the exact opposite of what we did. Instead of being given a piecewise function and saying, hey, form me a graph, they're going to switch the roles around on you and say, here's your graph. Let's form a piecewise function. Now, piecewise functions. How many lines do you see up here, kids? So how many parts of the piecewise function are there going to be? Okay, what appears to be our parameter, or the dividing line, if you will? Looks like it's at what value again? 0 here again, right? Okay. So we come over here and we say, all right, we have f, I should give myself some room. Kind of move yourself down a little bit. F of x. And then you have to write this big, like, parenthesis thing, bracket thing. What do they call that thing? What's that thing called? It's not a parenthesis, and it's not a bracket. What is that thing? So I'm the only one that doesn't know? That's good. I'm okay with it then. Let's just call it the piecewise thing. We'll call it pennywise. How's that sound? Let's work left of 0. Okay? Kids, do we know the y-intercept here of this line? -2. How about the slope? -1, is that right?
Yeah.
So do you agree that this one on the left is like a negative x minus how much? That line is negative x minus 2. So we would say f of x equals the following. It's negative x minus 2 for what, kids? Okay, check it. Am I left or right of this line 0 for this? All right, so it would be for x values. Okay, let's see. Left of 0. So is that less than or greater than? Less than. So am I going less than or less than or equal to? I want less than or equal to because this, my friends, is closed. We're including it there. So less than or equal to 0. Okay? That's the first one. Okay, do we know the y-intercept on this line? Looks like negative how much? 3. How about a slope on this one? Looks like I rise 2 and run 1, don't I? To go from here to here. Rise 2, run 1. So you guys agree that an equation for this, or an expression at least for this line, would be 2x. What'd you say the y-intercept was? Hey! So the other one's going to be 2x minus 3. Help me out, kiddos. For what?
Y is greater than 0.
Okay, do you want y greater than 0 or do you want x greater than 0? Why not greater than or equal to, Sam?
Because it's an open circle.
Open circle. So it's like saying start there, but we're not going to use that point. Okay? You guys, I tell you what, you're impressing me this morning. I love it. I know I went quickly through that example. You feel okay with it. So let's give you a chance to practice. You guys take 3 minutes and 14 seconds. And you try this one right down here. Don't worry about what this is, okay? Oh, by the way, did that ask for domain and range? Oh, good, good, good. No domain, no range. We're good. You guys try the right one there. This one, my friends, is a little trickier. How many parts are there this time? So how many functions are you going to have to write? Okay. I expect a little bit of a struggle with this one, okay? So see if you can get through it. I'm curious to see what happens. Show of hands. How many at least agree that this one's harder than the one we just did? Show of hands. How many do you want me to get you moving on this? Okay, let's talk here quickly. All right, this was probably a mean one for me to try and make you do alone. All right, it was. Okay, just say Parsons so mean, not cool. All right, I'm okay with that. Okay, first of all, this problem looks kind of tough, so let me do this first. All right, here we go. You guys agree, first of all, where are your parameters going to lie? I'm going to draw some dotted lines in here to help me with this. You guys agree that it breaks right here at -2? So sometimes I like to draw the lines in here to help me. I'm going to draw a line in here at -2. Where else do I have another dotted line at, kids? 1. Okay. So guys, when I write this piecewise function, how many parts are there going to be to this again? 3 of them. Okay, here we go with this. All right, I'm going to come down here. I'm going to write f of x equals, here we go, start our piecewise function. Let's talk about the part left of -2. Okay? Let's talk about the part left of -2. Now guys, I don't know what the y-intercept is, but could I follow this far enough down to know what the y-intercept would be? Could I do that? If I follow this line, keep going down, 1 over, 1 down, where's this going to hit for a y-intercept, kids? -2. And then how about your slope of this line, kiddos, on the far left? -1. So I know that first one, I call this section 1, section 2, section 3. I know the part on the far left is going to have a slope of -1, so I call it -x. Where would that intercept be if I followed it again?
-2.
Yeah, good. Now, this is for what values? Give me a show of hands when you think you know this. For x. Logan, what do you think?
Less than or equal to 0.
Less than or equal to 0. Careful. Because where does this stop at? -2. So am I left of -2 with that or right of -2? So instead of less than or equal to 0, you want to be less than or equal to -2, right? Does everybody see this down here? This part of the graph, part 1, is graphed to the left of what value? So all x values less than or equal to what? All right. All right, let's talk about part 2. Part 2 is a horizontal function. So what's the slope of any horizontal function? 0. So this is like 0x. What's 0 times x going to be anyway? So any horizontal function is just like a y-intercept. Where would this cross, or where does it cross? Crosses at 2. So the second part is going to be it just equals the value 2. It's a horizontal line. And this is the tricky part. Watch what I write. The function is at 2 between what values, kids? So greater than -2, but less than, what is this right here? 1. And this is the way you write this. You write -2. So it's like all x values bigger than -2 here. That's this way. And all x values less than 1. Why did I just put less than signs in here, kids? Yeah.
Because if you just get rid of the less than 1, then it's, you gotta reverse that.
Right, right. How come I didn't put equals down there? Yeah, because these dots are what here for that part? Open. Okay? I'm not talking about part 3. Somebody is going to give me the answer to part 3. Part 3 have a slope. Would part 3 have an intercept? Allie, you want to run with it? Okay, I'm listening, kiddo.
2x.
So the slope is 2.
Yeah.
Rise 2, run 1. I agree with that. 2x.
And minus 2.
Okay.
Oh,
So,
wait, no, it's minus 3.
so my slope would continue to come down 2 and over 1, right?
Yeah.
So it actually, if I extended this way a little bit, it would end up right down there, wouldn't it?
Yeah.
So,
Minus 3.
yep.
And then x is greater than or equal to 1.
Yep. It's at 2. Or I'm sorry, at 1. Did you say 1?
Yeah.
Okay, at 1 is where this break line is. There's a dot on it that's closed, and we're to the right. So that would be for x values greater than?
Or equal to 1.
Yes. Holy smokes. Does it help you to break it down in parts like that? That's my first question. Okay. If it doesn't, fine, just do what you need to do. But may I tell you what, for a guy that was born north of Highway 3, I have to break it down like that. All right? Okay? I think we have time to get through example 4. I'm not sure we'll get through example 5. Is that okay today? Okay. Just a reminder, I sent out a new online page, so at least try and get started on that. Won't be due until Friday night late. So we'll give example 4 a shot. Give me a show of hands. How many are at least kind of on board with me right now? A little bit? Okay, if you struggle, come and visit with me. But and honestly, this stuff will get recorded. It'll be up on the website here in a little bit today too. So if you ever need to go back and rewatch something, I would strongly encourage that as well. Right? Okay, let's tie this up here with example 4. Ooh, I kind of like this one. Okay, graphing and writing what's called a step function. All right? It says, kids, this. You rent a bicycle for 4 days. Okay? The bike store charges $20 for the what? And then $15 for each additional day. Write and graph a step function that represents the relationships between the number X of days and the total cost Y in dollars of renting the bike. Okay? So let's just go over here. Let's call this X, and this is my number of days. And we'll call this Y, and this will be my total cost up here. Okay, so on that first day, we say, hey, I need a bike. What's the cost going to be on that first day, kids? 20 bucks. Okay? Now, when I walk in there, it's like time just started. I was at 0, and I go all the way up to how many days for it? 1. So like in this right here for X, like 0 to 1, you're paying $20. Now, the second day comes. You're going from day 1 to day 2. How much more is each additional day now, kids? $15. So $20 the first day, you're going to pay $15 the next day. What's our total cost after 2 days? Now, kids, if I ride for the whole first day, and then the second day I only use it for an hour, they're still going to charge me for how many days? 2 days, right? Okay. Then day 2 to 3 comes. How much more on top of that? Well, we're up to a total of how much now, guys? Okay. And then finally, day 3 to day 4. What's this going to look like? $65. Okay. So here's what we have. We have a table of information. I'm going to make a graph of this first. Okay. I'm going to come down here on this x-axis and label this days right here. And I'm going to label this my cost. I'm going to go by, let's go by tens on this, okay? And then down here we'll go by ones. Okay? So guys, on that first day, what was our cost? $20, okay? So this is gonna be a graph that starts here at 20, and at the end of the first day, and end there, okay? Now, what was our total cost from day 2 to day 3? 35. Now, what I do here, guys, is this. Since day 1 ends at 20 right here, I come up here and I put an open dot at 35. And I say, okay, if I go any time beyond that open dot, hang on. Oh, Lordy. That's why masks are no good now. Sneezing. No. You're at 35, and you close it up there because that's the very end of day 2 at 35. Then day 3 to day 4 happened, kids. Or no, I'm sorry, day 2 to day 3. What are we at to our cost from day 2 to day 3? 50. So open on 50 from 2 to 3 and over. You guys see why they call this a step function? Kind of like stair steps moving up, isn't it? Okay, and then finally, what did the total cost end up from day 3 to day 4? So I'm in between 60 and 70. That's what your step function would look like. Okay. Now, kids, we'll write the piecewise function tomorrow. I'm going to upload this here in a little bit. I did send the online page out. We have one more example to talk about, but I do believe that you've got a pretty good background to at least get started on that online right now. Okay. What questions do you have for me right now today? Okay. Very good. You guys keep up the good work, and Alexis, some of the stuff that you guys send online, if I don't send an email back about feedback with anything,